Welcome in the tutorial video where I will be showing you how to work with the new R package RVEC. The package is able to transcript a phytosociological relevance into the simple CSV vegetation tables, which can be later on analyzed in the R environment with other packages. For this guide, I have scanned few of my relevance, so you can take a look. And our goal today, transcript this vegetation relevance into the PC with the RVEC package. I will show you step by step how it can be done, and you will understand how RVEC works. So the first most important thing is to get the package. It's completely free and it can be downloaded from the CRAN repository or alternatively from GitHub. So for the official installation from CRAN, we can run function install packages with the name of the package RVEC, and later on loading it to the library. So that is one possibility. And the other option, alternative, is to install it from the GitHub, which can be done with the package DevTools and function install packages, install GitHub with the link to the package, which is SESITCSL2 RVEC. So that would install the package. I will not run these functions right now because I have already the package installed on my computer, so I will just load it into the library. Now if I run the help RVEC, we can take a look on the package structure. So as you see in my R environment, I'm using RStudio, but you can use anything else. Here we can see some description of the package. As you can see, another option is to, if we run the this function, we will get a PDF manual. So here you can read some details about the package. And when we look here, we see that the package has 6 functions. Starting out with the add relevant function, which is the most important and main function, and which allows you to create the relevance and edit them in a database. And the other function is just addition to it and modifying the relevance. So in this first video, in this first part, I will explain you the add relevant function step by step. So we can start right away with the add relevant. As you can see, there are 4 arguments, while the first argument database is for the editing of the databases. So if we would already have a database, we would have to fill the name of it. But we are creating new database, so we can leave it blank, actually leaving it to the default. But we have to insert the name of our relevant. So for example, this can be named as example video. Other arguments are checklist and extra head, while checklist is the list of the species. It's default part of the package, and it's checklist from Danny Helka, but you are able to add your own checklist of species. And the last argument is the extra head, and that is for the header. If you wish to add some own characteristics, but it's not necessary because there is a prepared structure of the header. So if we run this function, let's see what happened. Now take a look at the console window here, and we see that automatically we started creating our first relay, starting with the header data. So the first characteristic it needs to be filled is date, and as you can see there is some recommended format, but it's totally up to you as with every other characteristic because it's just simple text string. So there is no need to follow the format, but we will for this. So for the case of my releva, it was taken on 18th of August. So I will fill it here. Now there is a spring date. If we would have two samplings, one done in spring. If not, you can leave the fields also blank, empty. So I will do that. Locality was Ocha in Hungary. Field code 47, that is code of the releva to distinguish between the more relevas in the same locality. Author was the me. So again, you can use any format you want for your relevas. Latitude. I will now make something up because I don't see it in my notes because I have scanned it incorrectly. So let's write something here. But I can see my longitude, which is 19.253493. Accuracy 3 meters, for example. It was done not in, there was no slope, there was no exposure. And now we are already filling the coverage of the different layers. So starting with E3, the tree layer, I see in my notes here it was 80%. The shrub layer was 5%. Herb layer 70. Juvenile 7%, and moss layer was 5% again. And now there's last characteristic node. If you want to add some extra nodes, I don't need, or I can write here something like check latitude for later on to check latitude. So now we filled out the header, and now it's time to start writing the species. So it asks me, it's like having a dialogue with the RVec. So it's asking me add a new layer. I'm saying yes. Let's start with the tree layer, writing 3. And my nodes are in brown blanket scale, but you can also insert the values in percentage. It's up to you, depending on your nodes. I know there exist many more scales, but they are not included in RVec. But it's not that complicated, let's say, so they may be added in future if there will be a demand for it. So I will be writing BB like brown blanket. Now you can notice that I'm writing it small, even though there is the uppercase. It shouldn't matter. The RVec should be resistant to this. Okay, so now adding a species. So The way how it's work is that you write the code of the species which is included in the checklist. We can take a look on that. The checklist look like this. It's simple text file with 3 columns. The first one is the ID code for the species. So for example, I can see that Carpinus betulus has code 2315, and it has a short name, the special code named CARE-BET, which is the short of the and this code is made by the genus and the species name. So take a look back to R, and the code should be made like 4 first letters from the genus and 3 letters from the species. So we can try that. So I see in my notes that there was Alnus glutinosa present. So I'm writing first 4 letters from the genus and 3 letters from the species name. Abundance was 4 on the brown blanket scale. And now there is a double check. So the RBAC is asking me if I meant the Alnus glutinosa species, and I meant, and it's right. So I'm just saying yes. And just like this, you fill the whole relevant. So my second species that was in the 3 layer was Fraxinus angustifolia. So I'm writing Frax ang with the 2A. It's enough to write A, and it's correct. As you can see, now you can notice 2 things again. At the first time, I wrote in Alnus glutinosa with the uppercase first letters. In the second case, I made only first letter uppercase. It doesn't really matter. The species name, this is my relevant already, so I can see there are 2 species, and the code is enhanced by the number, which is saying me in which layer the species is. So 3 for the 3 layer, and as you can see, the brown blanket values are transformed to the percentage. So I filled all the 3 layers, so now I'm saying no to the RBAC because the 3 layer is done, and I'm saying add new layer. Yes. Let's going for the shrub layer, and I see there's Populus alba, again brown blanket scale, and Populus alp in 2M, and it's correct. So that is all in the shrub layer. I'm saying no more species. Now let's do the herb layer, brown blanket, and I will be now just filling the species. So now you can see how quickly you can actually work in R. But before now, for example, I'm going to add Lycopus europaeus, which should be Lyco-euro with the 2M. But as you see, the RBAC actually doesn't recognize the Lyco-euro code. So in this case, it happened that the species have different code than we would expect. So if that happens to you, and it happens, in the double check you say it's not correct, and you'll have to search for the correct code. So one option would be to check manually into the text file, into the checklist, but you can do it also in the RBAC, of course. So you write the first 3 letters of the species, and it will print you the list, and you can search for the name. So as you can see, Lycopus europaeus has actually named Lycoeuro. So let's write that. Double check it's correct, and now it's part of our Releva. So just like this, I will fill the Releva. So as you can see, it can work quite quickly because I remember the species and their codes already for some. So let's fill this first Releva. After some time, the species are repeating, so you memorize the short names. But as you can see, for example, on Caltha palustrales, the code is different, so I'm gonna look for it, and I see that the correct name is the we have to find the correct name here. Yeah, it's usually sorted alphabetically, so I should look here. Caltha palustres has the code calfpal for some reason. This can happen, for example, where when the two species would have the same code, so probably the short name is already reserved for another species. So that's all from my hair player, if I'm seeing it correctly. So no more species, but I'm also going to write the juveniles, which is Fraxinus angustifolia, Acer negundo, Populus album, Popu alp, M, and Quercus robur, and R. Correct. Okay, so now I'm saying no more species, and I don't have any other species in another layer. So I'm saying no, and it tells me the final species richness, which is 18. It's important to note that every species in each layer count as one species, so we can check if we actually transcribed whole Releva. So I'm gonna count the species. 10, 18. So all species are in the relevance. And now we ended up in the main menu, where we can actually run other commands. Already, while we are doing it, the RBAC created the files, so we can take a look. The RBAC database is consisting from the two CSV files, one for the header, one for the relevant. So already now, if we would stop writing and we would stop the script, we have our data saved. That's important to know. It's saved in the after every species. The relevant database is saved. So now in the main menu, we have multiple options, and we will explain them later. If you want to add another releva, our first releva is done. If you want to add another releva, we write yes. If we write no, it will stop the script. the RREL and RHEAD is for the repair. If we actually write some mistake, we can also remove relevance, and we can take a look at our relevance. So if I'm writing print rel, I actually see my first relevance, and if I'm gonna write print head, I can see the header of the first relevance as well. And after we will have more relevance, we will see all of them here. So for that, let's write the second relevance. So I'm gonna change the images, the scans. 48 now. So now I'm gonna rewrite this part. There's much more species, but I'll write just some of them just to explain. So the date is the same. 19, locality Ocha, field code 48. And now we can demonstrate the case that we make a mistake here. So for example, instead of 200 meters, I will write 2000 meters, and I know it's incorrect, so I will have to repair it later. So the coordinates, here's 2 meters, no exposure, 3 layer 30%, shrub layer 10%, hair player, juveniles. Is there no juveniles? Oh, I think I didn't scan it again. And no animals 5%. No note for this case. And now we just repeat the same process as before, adding all the species. So I will quickly do that. The layer 3 layer, brown blanket, starting with Aulus glutinosa, 2A, correct, Fraxinus angustifolia. Now I can demonstrate what happens when you write the incorrect name, for example. So if you write more characters, it will just ask you again if you don't fill it correctly. But what can happen is that you enter the wrong name, then yeah, let's take a look on that. So now you have to search for the name in the list. So you know it's Frax Ank. But if we would accidentally written the code for a different species, which can happen, we would just do the same process. We would decline in the double check, and we would have to insert it again. But what can happen is that we actually wrote incorrectly the cover. So let's try that. Now I'm writing Fraxinus angustifolia into the shrub layer, and I know it should be 2M, but I can make a mistake here and I will write B. So now I see the cover is much more than it should be. So easily way how to fix it is just to write the species and it will rewrite itself again. So now I'm writing M, and as you can see the coverage changed. The same would be if we would accidentally insert the species that is not in our relevant, for example, for trivialis on 2, and I see, and you see now it's in my relevant, but I I know it's not correct, so you can delete it by giving it a 0 cover. And now it's not part of the relevant anymore. So that was just some things to note. Also, we have Alnus glutinosa in the shrub layer. We have some species in the herb layer. Solanum dulcamara. So the working is quite fast if you got it in hand. So I can fill the whole relevant like this. And now it's no, it's correct. Hydropipera. It is Pseudocoros, Cardamine dentata, Lysimachia vulgaris, Scutellaria galericulata, Lytrum salicaria. I made a mistake here. I know. So for this one, is the double check very useful. Okay, now we can demonstrate another. Okay, now we can demonstrate another thing that can happen is that you are not able to actually determine the species and you only determine the genus. In this case, uh, the checklist is containing the species as well. So if I scroll back and you see that I was searching for Lythrum, there is also possibility to insert the Lythrum species, which the code is then created by 4 letters of the genus, this symbol, and SP. So theoretically, the Rhodepa species would be Rhode sp, R, and we see it's correct. In a similar way, you are also able to insert the aggregates and sections. I can show you that in the Angelica checklist. So for example, when I scroll here, I can see that if there is some, I can search for it. So for example, Achillea millefolium aggregate, it would be 4 letters of the genus, hashtag, and 2 letters of the aggregate. So Ache hashtag me. So let's continue. Calistega sepel. Okay, that's my herb layer, and now also juveniles, brown blanket, Frangua aunus, R, Aunus glutinus plus and Fraxinus angustifolia plus. Okay, no more species, no more layers. Now I will check the numbers of the species, and we have two relevance already in. So we can take a look. Print row, print relevance. We see and print head the same. We see that there are two relevance. Field code 4748. Oh, but now I see two mistakes here. I've inserted the 2000 here, and here, as in my note says, the latitude is wrong. So how can we now work with this? So for now, I can show you the two options. The correct way would be to prepare it straight in the RVEC. So let's do it. Head would prepare the relevant header. So it asks me for the number. I will start with the second one. So relevant number 2. It will tell me the characteristics, and you have to confirm, double check always it's correct. And I will be repairing the plot size. So let's write plot size. Oh, yeah, you have to say that you want to repair something here. So let's repair the plot size. Here I think it's important to keep the letters in the correct size, and you will use 200 actually. Nothing more to repair. And now when I look to header, it's repaired. Now I will stop the script for a second, and we can take a look on the files we created. So you see it creates two files with one with the rel on the end and one with the head on the end. So in the name, so easily distinguishable relevance and headers. So, and it's a very simple table, and in some cases, but I really do not recommend it, you can actually modify this table, but you have to keep the format the same, and it's not always the same because if we take a look on the file structure, for example in WordPad, we see that the separator is the comma, but in some cases, yeah, if you want to make any changes, you would have to keep the structure the same, so separated by comma, and do not change the separator. For example, Microsoft Excel can change the separator automatically to the one that is native to your operating system. But if your native separator is comma, it should work. So we can try now edit the header value here. So I can see that I have written wrong latitude, so I will repair it here, save it. I'm gonna check that it's still with the commas. Yeah, it's correct. You can change it also in the Excel or in other software, but be careful, do not change the name of the row names and the column names. Do not change that. And now we can simulate the situation. For example, you are writing a lot of relevance and you want to take a break and write more relevance later. So in that case, to keep editing the database, we would need to run the command add relevant again. But now, the important is the argument database. We do not want to create a new database, so we want to edit existing one already. So by the name of our database, example video, we would start editing this database. But we again have to also make the argument save. And there are like two options now. We can either save it again as example video, which would rewrite our database, or you can, for example, create a new name so you have also backup, to make a new file. So you'll do that. As you can see already, after we start, it created the files. So now we have a new database here. And if I will now run print head, I see our repair in the Microsoft Excel went correctly. So that would be about the files. The repair releve I didn't show, so I can show you also this function. You would similarly just enter the releve you want to edit. So for example, my first releve, yes, it's the correct one with the field code 47. And you have to just say add new layer, and you can enter the layer again and edit it. So for example, I see the juvenile for the quercus is too low, so I can change it for a plus. So you can see it change it from 1 to 2, or you can also add a species or delete species. So I can, for example, add a juvenile of Frangua alnus with R, and you see it here. You can note that this list is sorted by the code, so it's alphabetically, but it's separated also by the layers. So first species are in the tree layer, second is in the shrub layer, and so on. So that's how to edit the releves. We can check if everything went smoothly. Yes, it seems correctly, perfect. And another thing, the last function in this menu is a remove rel, which will simply delete the releve and the header as well. So let's remove the last releve, and if I will run it now, I can see there's only one releve. So so that would be it. Let's stop the script, take a look on our files, and if we look here now, it's only one releve and edited as we edited it. So that is everything I want to show you, I think. That would be the first video guide about the function of add releve. I might also create more instructional video about these functions, but they are not that complicated, and we will see. They are not so important, but they can be also very handy. So thank you and bye. If you have any questions, or would you need help with anything, or in the other case that you discovered some unwanted behavior of the software, some bug or errors, I would be very happy if you could send them to me. So so you can send and communicate with me on the maintainer email address right here. Or in the case you would like some upgrade, some mm, additional function to RBAC, I will I can also add them later.